Complex numbers are numbers that have the number I in it, and I is the square root of -1. So pretty much we're given a negative square root, so say negative square root of 4. This is not a real number, but it is a complex number. So what we would do first is we take out this I. What that's going to do is it's going to take out that negative for us. So we have I square root of 4, and square root of 4 is a perfect square, so that's just 2I. Those ones are always really simple. Let's say we have square root of -8. We still have that negative inside, so we're going to take it out. But now 8 is not a perfect square. So off to the side, we make an 8, we make a factor tree. So what times what equals 8? So 4 and 2. 4 can be broken down more into 2 and 2. When we have this factor tree broken all the way down, we look for pairs. Pairs means one of those can come out, so one of those 2's can come out with the I. This other 2, it's going to stay inside the square root. So square root of -8I is 2I square root of 2. And let's do one more example. So let's say we have the square root of -45. We take out the I, so I square root of 45. Make a factor tree. So 45, whatever you can think of first. First one that comes to my mind is 9 and 5. 9 can be broken down to 3 and 3, and we can't break it down anymore. So I have a pair of 3's. So I have 3I, and then 5 stays inside the square root. So that would be how we simplify complex numbers. When we're adding and subtracting complex numbers, it's pretty much combining like terms. So if we have this for an example, we need to simplify those complex numbers. So we're going to take out our i's on both of the square roots. Minus does not affect it in front, a number in front doesn't affect it either. Since these are both 27s, we only really need to make one factor tree. So we have 9 and 3. 9 breaks down to 3 and 3. Okay, so this first one would break down into 3I square root of 3. This plus 4 doesn't really change anything at all. It just stays there. Since I already have this 2 out here, when I take out this 3, I'm going to multiply those together. So 3 times 2I square root of 3. Then just go ahead and multiply the 3 and the 2 together, which gives us 6I. So when we're combining these, they both have to have an I to be like terms. They also have to have the same square root. So I square root of 3, I square root of 3, we can combine those. So 3I square root of 3 minus, gotta have that minus in there, 6I square root of 3. It's -3I square root of 3. And that plus 4 is just going to be out there on its own. Let's take a look at a few more simple examples. So let's say we have 3I plus 2I minus 5I. So since all of these just have an I, we can just combine them from left to right. So 3I plus 2I is 5I. So bring down the minus 5I. 5I minus 5I, everything goes away. It's just 0. So that's it for that one. Let's say we have another example. Let's go 2I square root of 3 plus 5I square root of 7 minus 8I square root of 2. So these all have i's, but none of them have the same square roots. Since they don't have the same square roots, we can't actually combine any of these. We'd be done. And one last example. So we have 4I square root of 2. So we look through these, see if we have any other I square roots of 2. So we have one right here. So we can combine those. The 5 is an I square root of 3. So we look through for an I square root of 3. And we have that exactly right there. So we can combine the I square roots of 2's and the I square roots of 3's. So we have 4I square root of 2 plus I square root of 2, which is 1I square root of 2, which gives us 5I square root of 2. And then if we combine negative 5I square root of 3 minus 7I square root of 3, gives us negative 12I square root of 3. Essentially, adding, subtracting complex numbers is just combining like terms. So figure out what has the same I, same radical, combine them. If you have any questions, feel free to either email me or contact me in class. I hope this helps.